grades and everything are kept, and how long they do each lesson, how long they watch it and everything, and they rewind it and everything. And they do all of their testing grades for that, plus they can even do exercises online and everything. So, yeah, one of the California school districts did that.
I'm not sure how I feel about
Well,
some of the, well,
I thought you were going to say what the results were.
well, yeah, they would, yeah, their grading and everything would be kept up to date on the online.
alright.
I can't remember what it was, but it was really cool. Like,
Yeah.
So guys, I want to start off asking you a question we've already worked out, which is always nice. Then we'll do a question that seems easy at first, but you'll tell me that there's a problem with it, which will be nice. So let's start off nice. If I had this is semi-nice. You've already done it. Let me just see if everybody remembers what to be careful about here. What can you do?
Plus or minus.
Beautiful. So square root both sides to kill that square. Now, one reason why this is true, why you automatically put a plus or minus, is because what is the square root of x squared officially? Absolute value of x. And if the absolute value of x equals 7, then x equals plus or minus 7. Right? Shortcut all that, just put a plus or minus whenever you take a square root. You got to put that plus or minus down to capture both answers. So x will equal plus or minus 7. Because again, if you brought the 49 over, how do you factor that?
X plus 7 and x minus 7.
So then you get x equals negative 7 plus 7, right? So if you forget the plus or minus, you're losing one of the factors. You're losing one of the answers. Okay, cool. Here's another one. Now, before I get into the thing I said you tell me there's a problem. What about, yeah, this here? Same thing?
It would have an I.
So the minute you put square root down, you got to put that plus or minus. Make it a habit. So you get x equals plus or minus 2i. I like it. Square root of 4 is 2. It's negative, so it's got to be imaginary. Now, some of you guys might remember, if you were here last time, if I had this problem, I wanted to try to do it factoring-wise, what would you do?
Got it.
Add the 4 over. Now, right here, we would be stuck. You can't factor that using real numbers. But we have progressed beyond that. We have evolved. I can factor this. X squared is x and x. To make plus 4, I actually need to have not plus 2 and minus 2, because that would make minus 4. Plus 2i and minus 2i, and that's another place where we can see where that comes from. Plus or minus 2i. Right there. So I know we had a little trouble last time I was trying to explain to you why you can factor it like this. It kind of comes out a little bit easier if you see to solve it one way. You got to get the answer the same way. I mean, the same answer if you do it another way. You're going to get x equals plus or minus 2i. Cool. What does that mean about this? If you graph this parabola, who can tell me what would that parabola look like? What's the y-intercept of that parabola? Parabola. Y-intercept is 4, right? You always find the y-intercept by setting x equal to 0. And it would open up. So would it ever hit the x-axis?
No.
It starts there and it goes up. That's why the only answers are imaginary, because it never hits the real x-axis. How we know? There's an entire branch of mathematics about graphing things on a complex graph. We're not going there. But I want you to realize when you look at the real graph, you're losing information. You're actually not able to see the complex answers. That's why there are answers when it looks like when you look at it visually. You know, how could there be answers? It doesn't hit it. Well, that's why they're imaginary. They're not real. Real numbers would show up here. Okay, all right. So what about the freaky one I said? You tell me what's wrong. Why does it make sense here? I got plus or minus 7, plus or minus 2i. Why does it make sense I keep getting two answers? Because this is second power, right? If I had a third power, I need to get three answers. Right? So what about x cubed equals 8? This one seems at first glance, you're not going to get enough answers. What do you do? How do you solve this? Cube root. Cube roots don't have the problems that square roots do, right? So I don't put plus or minus. I get x equals,
Plus or minus 2.
no, don't put plus or minus.
Oh, that's right. Okay.
Odd roots do not have the problems even roots do. Cube root of x cubed is x. It's not an absolute value of x, right? So what's wrong here? We expected how many answers? We only got one. That's no good. Where are the other two answers, right? And this is kind of motivation for what we're going to get into. I know you all know what's coming up. You've at least heard of it if you don't remember it. Quadratic formula. Yeah. If I solve this factoring wise, and you can see how factoring saves my ass. If I forgot the plus or minus and I did a factoring, oh shit, there's supposed to be more answers. I forgot the -7, right? Do you guys see what I'm saying? Square root of 49 is 7. Ooh, I forgot the plus or minus. Because the factoring saves my ass. Here we did this, we're like, oh shit, I did something. I must have. Let's try the factoring method. And of course here I'd subtract the 8. How do you factor that? Little review here.
X minus 3.
I like it.
X squared.
Plus 2x.
So there's my 2. Here's my other two answers, and they're gonna be possibly imaginary, at least ugly, right? Irrational answers. But it definitely could be, in this case, they're going to be imaginary. Do you guys see? So this totally gets lost here. We don't even know how to solve this right now. We don't, because the answers are going to be ugly. We don't have quadratic formula under our belt officially yet. I know some of you guys know it. You should be able to maybe rattle it off. All right? We'll get to it. So this is not this section yet. This is a little motivation for later. It's coming. Okay. So it's pretty straightforward though. These are really freaking nice. You can't beat these problems for ease as long as you don't forget the plus or minus. And here's even just a slightly uglier problem. That's still good. This should have a very familiar feel to something I keep saying. When you got absolute values in an equation, when you got square roots in an equation, what's your first step?
Isolate.
Isolate the thing, right? Wherever the x is stuck, you get that alone first, because then you can attack why it's stuck. If I took a square root right now, that would so suck, because the plus 3 gets in my way. So get the stupid thing out of the way. Right? Subtract 3. And then what can I do to both sides?
Square.
Square root, and I automatically do what when I do that? Plus or minus. Now here, be careful, the square root and the square root cancel, you get a nice x minus 2. Right? There's not another x square root there somehow. Equals plus or minus root 2. And what's the last step here?
2 plus minus.
Yeah, just add the 2 over, right? People get a little confused about this plus or minus. There is no plus or minus button on your calculator for one thing, but it just means you have two answers. One of them is going to be 2 plus this, and the other is going to be 2 minus that. Because when I add this, you can't put it there, because I'm not multiplying by 2. It's going to be 2 plus or minus root 2. You can do it, Jeff. There you go. How we doing? But I always have somebody like leapfrog that somehow get it there. That's neat.
When you have the imaginary numbers, does it still have to be in that A plus BI form?
Yeah. So I could have made this one that way. In fact, I was debating on whether to do that. What about this problem here? You guys try this one. Well, I can make it. Yeah, sure. This is going to be a little ugly. Let's make it. I won't make it overly ugly. Yeah.
Is this just a way to, an alternate way of, instead of factoring it all out, to get the answer?
This is, it's called the principle of square roots, which I find hilarious, because it's how do you solve an equation? You get x by itself. How do you do that? You undo everything being done. So since I'm squaring, I'm going to square root, right? The problem is they're not all going to, see how, this is actually a really nice equation, because this is where all my x's are. There are no more x's around. So they're already kind of gathered together for me. The next level is where they're not gathered together for me. So I either try to gather them together, or I attack it with a brute force thing like Quadratic Formula, which is just chugs at it, right? What's the first step? Yeah, move the 7 out of the way. Isolate where that variable is stuck. Then you square root it. So it's kind of nice there because I made it a nice 4, right? Plus or minus. Get that to be a habit, right? The minute you take a square root in an equation, put that plus or minus symbol down there. I'll do this side. Yeah. Square root of 4 is 2. The negative's in there, so it's got to have an I to represent that. 2 steps and you're done.
Why?
Oh, sorry.
Why would you still say plus or minus? Because on the previous exercise, we would break that -4 down to -1, square root of -1, and then square root of 4.
It has nothing to do with the number. It has everything to do with the fact that I'm taking a square root, period. I don't care what's there. If you take a square root in an equation, you have to put the plus or minus down to capture both roots. This is going back to, if the square root's written for me already, if I got a square root of 9 staring me in the face, the answer's 3. It's the principal root, the positive root. Remember that? How many roots of 9 are there? How many square roots of 9 are there? 2. Plus 3, minus 3. So in this case, we have something squared equals 2. So it could be positive root 2, or it could be negative root 2. That's why I've got to put the plus or minus. The fact that it's complex is its own thing, right? What am I doing? I'm taking a square root. Oh, I better put plus or minus down.
Because we didn't do that in the other section. We were breaking it down. We didn't put plus or minus.
Because I didn't have an equation. I had something like square root of -81. It's sitting there staring me in the face, right? So it's already somebody else decided they wanted the positive one.
Okay.
It's already plus square root of -81.
Okay.
Whereas if I had this, 2 things squared give me -81. The positive square root of -81 and the negative square root of -81. Do you guys see the difference? This is already written as the positive root. That's why it always comes up positive. Here, they haven't written the roots yet. So which roots do they want? Both of them. They want the answers. The positive and the negative square root. So this one would be just plus or minus 9i, right? So be careful. This is an answer. This is a very specific answer already. They just want it simplified. It's the positive answer already. This one, they want the answers. There are 2 answers. The positive and the negative. Yeah?
Why is there an I right there after the 2? Is it because there's a negative?
Exactly. The square root of -4 is square root of 4 times square root of -1. Square root of 4 is 2. Square root of -1 is defined to be I.
What happens to, like, if there's a negative inside of the radical, then it's not real or something like that?
Yeah, it's imaginary, exactly. Because we can't do the square roots of negative numbers using real numbers.
So we end up putting an I in there too.
Exactly, to signify that it's complex. Cool. Okay, and that, you have to agree that that looks a lot better than that did. Right?
And that's the final answer?
Not done. Why am I not done yet?
But it's not
Yeah, so everything we've ever done is still got to be the same. I mean, the only way to solve an equation, I don't care what the hell the equation looks like, is to get to the point where x or t or s or whatever the variable is equals number or numbers. So I know I'm not done yet. I just do what I always do. What do? Add 5. 2x equals
5 plus or minus 2i.
Mr. God, don't write 7i there, right? You can see where that comes from, but they're not like terms. Plus, you got two things here, plus or minus. And then the last step. And I would highly suggest you do this. It doesn't really matter truly, but remember, it's got to be written as a plus bi. It's sort of like putting in mx plus b form. You want to see the slope and the y. Here I want to see the real part and the imaginary part. 5 halves plus or minus I.
Isn't there another way of doing this?
Yes. The way it's written, I would do it this way, because it's quicker. You might be thinking about quadratic formula, which we're approaching.
Okay, that's when you
We're getting to it.
take one down, put it back up.
Oh, that's synthetic division. Yeah, that's...
No, it's not synthetic division. I'll bring it up to you later.
Okay. Maybe there's a way I haven't heard of yet. No, it probably is. I don't know everything. Ain't nowhere near. I ain't got that much brain room. It's already full right now. Anything new, I gotta kick something out. All right.
I don't like that.
So, and really, I'm not saying that you should be comfortable with this totally, but you should realize this is not a big step from just solving any equation. It's the same damn thing. I mean, if I had the square root of 2x minus 5 plus 7 equals 3, what would be your first step? Minus 7, then you would square it. Now in this case it would be no solution because it's negative, but still it's the same. Subtract the 7, kill the square root. If I had the absolute value of 2x minus 5, well, the first step would be subtract the 7, and then set up your two cases, right? So here we just have another way to have the x stuck in a square instead of a square root or an absolute value. It's just all these ways of having the x stuck. I want to get it unstuck. Same stupid idea, right? So here we go. What about if it's not in this nice form like this here? I mean, this is a nice form because I can attack that directly. Right? What if it looks more like, what if not this, but this? Of course, what's your first thing you attempt?
Factory.
Yeah, and you very quickly see that factoring ain't gonna work, right? Some of you guys might realize exactly where I got this equation from, but we'll get to that in a second, right? I cannot just get x squared alone and square root both sides, right? Does everybody agree with that? If I put this over there, I'm not solving for x because I got an x on the other side. I get the square root of negative 2x minus 7. What the hell's that? Right? So there's got to be some other way. I can't factor it. I can't do it like this because all my x's aren't grouped for me already. So that's the idea. I want to somehow group my x's together and get something that looks like this. I want to get something squared. So hold on to this. We'll come back to this in a minute. So how to do this? X stuff. Okay, Jeff. Together. All right. So I'm going to show you why this method works. And the problem is people forget why it works, and then they get lost in the procedure. If you remember why it works, you'll be golden. So if I look at a couple examples, like x plus 1 squared, what do I get when I square that out? How does 2 relate to 1?
1 plus 1.
Well, let's double it, right? And how does 1 relate to 1? It's 1 squared. Let's get a little ahead of ourselves. What about, so let's try x plus 2 squared. What would that be?
X squared
Plus 4x, right? OI for the FOIL plus 4x plus 4. Again, 2 doubled is 4, 2 squared is 4. Okay, it's still not really evidence yet because you could say 1 cubed is 1. What about x minus 4 squared? What would that be? Good, x squared. Minus 4 is minus 8 plus 16. So now we can see it. Negative 4 doubled is negative 8. Negative 4 squared is 16. So see if you can go to the next level now, and to see how it's impossible to escape that. If I have something like this, it's going to have to come out like that. It's going to have the middle guy double this guy, and the last guy is the square of this guy, just because of the way that we multiply. So can you guys help me fill in the blank? Or the blanks. What has to go there to make this work? Not quite.
Five.
25. Now, remember, how do we figure that out? The number that is here is how related to this? That is double this. So this is half of that, right? So what number has to go here, actually? We can start there. It would have to be minus 5. It would have to be half of that. Negative 10 cut in half is negative 5. That's the number that goes in there. Now what's in, and so that's step 1. Step 2. So step 1 is cut the guy in the middle in half. Step 2 is square him to see what has to go there. There you go, right? Using the pattern. Math, a lot of math is look at the patterns, make a general rule, go to town, right? Now I can just apply that general rule every damn where. No matter how ugly it looks. Let's try an ugly one. This isn't even as ugly as I can make it, but let's just start here. So you first figure out what goes here. So what's that first step? Always, that first step is take the middle guy and cut it in half, right? So I get 5 divided by 2. Leave that alone. No, don't bring decimals in here. Second step. So that goes where? That goes here. Right? Now what number has to go there to make this work? Yeah, you square this piece. And that piece goes there. And sure enough, what's 5 halves x plus 5 halves x? When I start to FOIL this out, 5 halves x plus 5 halves x is a whole 5, right? When I FOIL this bad boy out, just kind of check this. 5 halves x plus 5 halves x is a whole 5. 5 halves times 5 halves is 25 fourths. How you guys feeling about that? I mean, it's all just noticing the pattern, and then just it's always the same damn thing. I don't care how ugly I make this. I can just throw a fraction in there. Let's try that last here, and then I'll show you the usefulness of this. Are you all sitting there going, "That's nice playing with numbers, Jeff. That's great. What the hell does it do for me?" So what about this guy? X squared. Let me make this particularly disgusting. Minus 1. I like it. That's gruesome. I like it. So the thing to remember, if I'm working with fractions and I have to divide by 2 or whatever, dividing by 2 is the same as multiplying by 1/2. Right? Just multiply by the reciprocal. So first step is cut this in half. There you go. So you get negative 11 over 8. So that goes where? Where does this go?
In parentheses.
Over here. Good. That's how it factors. Alright. And then what's the second step? Square this bad boy to figure out what goes there. What do you get? What's 11 squared? 121. 8 squared? Disgusting. And just realize why this is kind of silly. Why this is like, this is nothing magic. This is nothing amazing. If I FOIL this bad boy, I'm going to get 11 eighths plus 11 eighths in the middle, right? They're both negative, but just go with me. What's 11 eighths plus 11 eighths? 22 eighths, which is 11 fourths. You know, ooh. And then at the end, I'm going to get 11 eighths times 11 eighths, which is, of course, 121/64. That's why we squared it to figure out what went there. Do you guys see how it just, it's not that amazing. It isn't. So here, before I get too far, let me give you guys a couple that aren't that ugly. You guys try these. And I'm not going to say a word. For once. Alright, let's see. Oh, sorry.
The last one wasn't as easy as the first two.
No, definitely not. Because the first two are divisible by 2 there. Now, notice that this isn't really factoring. It's giving this side something to make it work like this if I factored it. I actually don't have to factor anything. I know this one is not as easy as these two, but it's barely harder. I don't care that I get fractions because just throw them in the right place, at least for right now. Later we're going to have to do another step. But on number 1, what's the first step?
Have it.
10.
Yeah, 20 divided by 2 is 10, and that goes where?
In parentheses.
Over here. And that of course is what would give me 10, 10, 20x in the middle. So far it looks good. Now of course the minute I put that 10 there, what has to be there? 10 squared 100. So it's kind of like, of course, it works because I'm making both kind of check each other off, right? This one's nice. The first step, negative 6 divided by 2. That's what goes here. And then square that. And we've seen this before, and we know that's how it factors, right? This is the only one that's ugly, but it isn't really that ugly even. First step, cut it in half. So that goes there. Second step, square it. 81 over 4, and that goes there. So that was all I had to do. All 3 of those are equally easy. I know I get fractions there. I didn't have to do a damn thing with them, though, so who cares? Just throw them in the right place, right? Now, of course, the first useful thing for this whole procedure, does anybody know what it's called? Sounds like something I would name it, which is kind of cool. They're finally naming it something I would call it. The whole purpose here is to put something in here so that this side would become a square. So it's called completing the square. What has to go there and there to make this work. I complete the square. That's what it's called. completing the square. Sounds like my completing the root. So what the hell is this good for? Absolutely. No, it's good for something. Bless you.
Thank you.
So I have an equation like this here. And I want to tell you something. I want to be, in all honesty, the use I'm going to show you right now becomes obsolete as soon as we do quadratic formula. But you can't have quadratic formula without knowing completing the square, because that's actually how they figured it out, right? And then when you go to the next level, very soon for us, there's going to be a whole other purpose for completing the square that you can't get around. So I know the one we're going to use right now is going to become obsolete very soon, but just deal with it. It's too bad. Just give you practice for completing the square. So if I had a problem like this, I think, what was the one we had up here earlier that I erased already?
Plus 2x minus 7.
Cool, thank you. So what number in there is wrong? I mean, what do I have to get out of my way so I can put the right thing there compared to what we were doing here? Where do we have blank spots here? At the end. So my first step should be get that 7 the hell out of the way. Why am I doing something freaky? Because I can't factor the damn thing. I need some other way to do this, right? So I have the 7 over. Make some room here. Now here I have an actual equation, right? Are you guys cool with, I always gotta be careful about this. Here I didn't really have an equation. I was setting up what this is. This isn't an equation. Well, I did put a 10 there, so I have to put 100 there. That's what I actually did to this side, but I want you guys to be careful. Whatever I put there, I've got to put over there too, right? It's an equation. So how do I figure out what's got to go here?
1 plus 1.
Yeah, first step, cut 2 in half, so I get 1. That's what goes here, right? So I'll be able to factor this side. Second step, take 1 and square it, and that's what goes here. So if I put plus 1 there, I better put plus 1 there. That's the thing that's so forgotten, and then you get funky answers. You're going to get funky answers anyway, so it's hard to tell why. But be careful. If you add something there, you better add something there. We've known that since day 1. Well, since day 0. So I get here, x plus 1 squared equals 8. Does anybody remember this from earlier? It was up on the board right before I wrote this. So this is my whole point. If they give me something that doesn't look like this, this procedure makes it look like this. And why is it nice if it looks like this? Because now I can just square root. Right? So that's what completing the square does for me. It takes a problem that doesn't look like this and makes it look like this. And this is relatively easy. Right? Square root and then I'm almost done. All I have to do is subtract 1. And of course, why is that not quite done? I circled it, but I'm not quite done yet. They're going to the moon next door, so I don't know if they're taking off. Yeah, what can I do with the radical 8? Yeah, radical 8 is radical 4 times 2, so that'll be plus or minus 2 radical 2. So it's just like at the end of a problem, if you get 8/10, you better not leave it that way. So if you get radical 8, you better not leave it that way. You got to simplify it, you got to reduce it. That's just something to do at the very end. All right, you guys try this one. this is where I was, now, the first step is cut it in half, right?
Correct.
And that's what goes in the factored formulas.
Okay.
So I'm kinda doing both of these at once here. The first step, that's what goes in the end. What's gotta go there to make it work? That thing squared goes there. If I added there, I better add it there. So now I've got the factored formula this side equals the number I end up with on that side.
Right.
And I can tack that directly.
Okay.
Right.
So,
Jeff,
Yeah.
on that one, how did you, on the second part, under the purple writing, the second part, you said 1 squared equals 1. How did you get 1?
1 squared.
Yeah, but how did you know to do 1 squared?
Oh, whatever I get there is what I square. Right? Whatever I get on this first step is what I square to figure out what goes there.
Okay.
Cool. So what do you do? What's the first step? Clean the square. Whatever's in the middle, cut it in half, and that's what goes. That's what goes here, right? I'm missing something here still. Second step,
Square it.
square it. And that's what's gonna go there. Now if I put it there,
You have to put it on the other side.
but I put it there. See how ugly it is. That's the step everybody forgets. Not everybody, but that's the step most often forgotten. Is whatever you put there, you gotta put it there also. It's an equation. You know you gotta do that. So are you cool with the fact, I kinda like doing it this way, because that first step tells you how it's gonna factor. You don't have to factor it, it factors for you. That first step tells you what to put here to make it factor. Second step tells you what to put there to make it work. Whatever you put there, you better put on the other side also. Now what do you get on the other side there? How do you put those together? That'll be negative 20 over 4 plus 25 over 4. Yeah, so 5/4. And then you can, and now you just attack it, right? This is what math is famous for. This is a problem from the previous selection of problems we did, right? And then when you learn something new, you're able to go from here and then just work your way back just to get back to here, right? So now what can you do both sides? You just take the root plus or minus. That kills that. What can you do over there? What's radical 5? Square root of 5 is, I don't know, what's square root of 4? 2. There you go. So you can simplify what you can. Yeah. Well, I have to have like denominators to be able to add those. It's just multiply by 4. Yeah, yeah.
And how come you wouldn't say plus or minus 2 at the bottom?
I don't have to. Right? I mean, root 5 over 2 is a number. I just have to have one plus or minus symbol. Right? It would be overkill to put that plus or minus down there, and in fact, it wouldn't really be right.
So you don't have to put the square root over the 5 and the 2?
No, because I didn't have a 2. I had a 4. And I did put the square root over there because I have to. But what is the square root of 4?
So it's not plus or minus square root of 4?
There's already a plus or minus on that number. That is one number here, isn't it? This is one number.
Yeah.
It's just have to have one symbol in front of plus or minus, in this case both, because there's a square root, but are you with me on that? I mean, if you had a negative fraction, but you did this, is it negative anymore? No. So
because
you want
how I did it, I put plus or minus square root of 5 over plus or minus square root of 4. And that's what you're
overkill.
saying?
Well, not even worse than overkill, because it's ambiguous as to what you mean. You have a single side here. It happens to be a fraction with a top and a bottom, but it's a single number, right? So you take plus or minus the square root of that number.
Okay.
Now the square root you can break up, but the plus or minus you can't break up, right? Do you kind of see what I'm saying? I mean, it's sort of like I was saying here, if I had 3/4 and I had to put a negative there, I can't break it up because then it effectively cancels itself out. That's not allowed.
So I guess if you imagine it's a 1 right there, plus or minus 1.
And it always is, right? There's always an understood 1 out front, everything, right? So really, I really want you to understand, let me do it. Here, let's see. When I have this, the process does not care what's here. The process says take the square root of both sides, put a plus or minus, bam, right? So, if you had this, do you care what that is first? What do you care about to simplify this? What do you actually look at? Square root of 16 is 4, and you put the negative back out there, right? So here, that plus or minus is kind of secondary. I mean, it's sitting out front, but how do you simplify square root of 5 over 4? You can simplify it as square root of 5 over square root of 4.
Okay.
You don't repeat the symbol that's sitting out front twice, right?
Because I always thought this plus minus went with the square root, but I guess it's not. It's
The minute you put a square root down, you put a plus or minus in front of it. But it's sort of like if I had negative square root of 16 over 9, and you broke it up, you wouldn't put negative, would you?
no.
Because then you killed the negative. How can you do that? There's only one negative for this number. So when you break the square root up, it's its own process, right? The negative doesn't care about what the root's doing. The negative is just like, I'm hanging out. Whatever the hell you do, I'm going to be the negative of you. So just do whatever you got to do, right?
Yeah.
Okay. So I just came out kind of weird. Plus or minus. And then the last step, subtract the 5/2. You can always put that bad boy right in the front. Negative 5/2 plus or minus square root of 5 over 2. Sure. Some of you guys might realize that does look very much like the answer you would get from quadratic formula, because we just did quadratic formula the long ass way. Quadratic formula is just a shortcut to complete a square. That's all it is. Okay. So since we're talking about quadratic formula, let's actually derive the formula once. If you want to look away and go, no, that's fine. They do it in the book, but I want to show you where the formula comes from. It's still 8.1 yet. Oh, and before I get in, let's do one last example here, because I don't know if you guys have noticed. Remember in synthetic division, what was one restriction? It had to be divided by, there's a couple restrictions, right, for synthetic? What has to be divided by what? What number is first? I can't divide by 2x minus 7, because the first number has got to be a 1. If you've noticed, every single problem we've done so far had a first number of 1. Completing the square is built on that idea that the first number is 1. So if I have a problem where the first number is not 1, Jeff, what do I do then? Tough guy. Let me see. Well, then I would still move the 10 out of the way, right? Add the 10 over. But then I would just cut everything in half. What to do, right? So I'd force it to be a 1 out front. Oops. Cool?
No.
What's not cool about that? Don't be joking me like that. Here, what's the first step? Yeah, cut that in half, so I get 11/4. Second step, square it. What are we getting? So that's what goes here, and here, and that's what goes there. And then there you just get your like denominators, but it'd be pretty much exactly like the last one we did. Are you guys cool with that? I didn't really want to do the whole thing out just to show you. If there is a number out front that's not one, divide by the damn thing. Then it is one. The reason I needed to show you that is because what's the most general form for this quadratic type thing we're working with? Ax squared plus bx plus c equals 0. That'd be a quadratic equation equal to 0, right? So the quadratic formula will solve anything that looks like that where a is not 0. If a is not 0, I don't need help, right? Subtract c, divide by b, I'm done.
When it comes like to test time, we have to do it each and every way if you're showing us today?
No. I'll be very specific, right? And sometimes I won't be specific, in which case you should use the quickest way, which is factoring if it works, or quadratic if it doesn't. Alright, so, bear with me now. I'm going to show you where the equation comes from. You're never going to have to do this yourself unless I give a bonus question that says, rederive the quadratic formula. What do you think the first thing I should do here is? I'm going to get a little help from you.
C.
Good. Get the c out of the way. So leave a little room here. Now I have to do what? Careful. No. I got to get the a out of the way, right? Complete square only works when the first coefficient is 1. Right now it's a. So I better divide by a. You see, let me get this over here so you guys can see this. Alright, so let me write where I left off here. So we subtracted the c, and we divided by a. Now watch, even if you're dealing with only letters, the 2 steps are easy as hell. What's the first step? You take b over a, cut it in half. Just, so you get b over 2a, right? And then second, and that's what's going to go here. Always. Now how to figure out what goes here? Square that. What's b over 2a squared?
Wouldn't that be bx?
No, not here? No.
No, in the middle?
Yeah, it is.
Oh, 'cause.
But I only look at, did I do 11x over 2?
That's right, that's right.
Times 1? Yeah, I only look at the coefficients, right? Are you guys cool with that?
Yep.
So I only look at the coefficient of the x for this step. Again, it's all in the book here if you don't want to write this stuff down. It's on page, oh, where the hell? Oh, where are you? Blah, blah, blah. It's here somewhere. Where the hell are you? I thought I was just like. Well, maybe I'm lying. Maybe you should take good notes. I'm surprised they don't have it in there. Oh, wait, they do, I'm sorry. I'm getting into section A too. So it's page 623. Yeah, page 623. You want to look at that. So what do I do with this? Don't be too creative with that. So what do I do with this? Yeah, put it there. And if I put it there, I better put it there. Stay with me now. You guys have tuned me on. It's all right. Now, what can I do on this side? How can I put those together? Which one's missing something? Yeah, the first one. What's the first one missing to be the same as him? Yeah, he's missing a 4 and an a. So now they both have 4a squared on the bottom, right? So I get this little dude just sitting there waiting. Over here I get b squared minus 4ac divided by 4a squared, right? Because it got like denominators. And then of course now I just attack it. I know this is disgusting as hell, but the steps are all the same. Steps do not care what's in there. What's the next step? Square root. Plus or minus, right? So you get x plus b over 2a. See if you guys can handle this. Can you guys handle this? What's the square root of 4a squared?
2a.
2a. And on top I get,
Oh my gosh, that's a quadratic formula.
I told you that's what I was doing. And the final step, subtract that b over 2a over I. So let me put it up here again. So if I subtract this over, don't they have like denominators? So now I can put it all, negative b plus or minus square root of b squared minus 4ac all over 2a, blah, blah, blah. I've heard songs and all this kind of shit. If
Yep.
you like,
Jingle bells.
if you like songs, great. I don't know.
I heard the most retarded song this weekend.
I hear a lot of retarded
For
songs.
this.
Oh,
But it was like an entire story about some little man who needed to know the quadratic formula, and it was crazy.
it's crap. Whatever works though, I don't care. If you have your silly song and it works, I love it.
What?
I can't give you some, I'm sorry. I just don't do silly songs. Really, sorry. I mean, it was like negative b, I can't remember.
X equals negative b plus or minus
Alright, stop.
square root.
I just don't think that's really helpful. Anyway,
It's catchy.
it's not even catchy, that's the problem. There's too much in there to be catchy.
It helps you remember it.
So, let's see.
Lost me, dude.
I know.
What's my, oh,
No,
if I
that,
lost you,
that.
if I lost you on this,
I know what the
That's
quadratic
okay.
formula is, but how you got there,
did some of you guys stay with me on that? I mean, the steps
Yeah,
we
some-
how
used
you got down
were the
here.
same steps. So this is the point though. If I put numbers in for A, B, C, and I did all the steps, that's the long ass way. If I start here, this is already solved. So that's why I said quadratic formula is a shortcut to completing the square, because it does complete the square first, before I even know what the equation is. That's why it's a shortcut. It gets a lot of the work done first.
Does that say 4ac at the top?
Yes,
Yes.
4AC. So somebody give me, what was this guy here? What was the answer he got for, what was it, 2x minus 7? Was that the one we did earlier?
Yeah.
What was the answer for that?
1.
1 plus or minus 2 square root of 2.
Yeah.
Alright, so let's do this again using quadratic formula. We already know what the answer should be. So we better get the same damn answer, or else we made a mistake somewhere, we can throw the whole thing out. So for quadratic formula, you just have to summarize what A, B, and C are, and throw them in the right place. In this case, what is A? 1. What's B? 2. C? Negative 7. So now you just gotta plug and shove, right? The biggest mistake I see is somehow that b squared term, even though it's never going to be complex itself, somehow it comes out to be negative sometimes. People forget that when you square negative, it should come out positive. It's only going to, A, B, and C for us are going to be real numbers. So that b squared piece better always be positive. So what do I get here? Negative
Plus
2 plus or minus 2 squared,
4.
4. That's 4 times negative 7. All over twice 1, right? And you just gotta chug away. What do you get inside the radical there?
32.
Yeah, 4 plus 28 is 32. Why am I not quite done there yet? Not just because it doesn't look like that, but why am I not done yet?
Because you can work with the 15.
Yeah, you can work with the 32.
16 times
negative 2 plus or minus 4.
Which
You sure it wasn't negative 1 as an answer here?
It's negative 1, yeah.
Alright,
Oh, it was, sorry.
that's better. As you can see, I'm going to get a negative 1 there when I break this up, right? To make that look the same as this, I can just break it up. Please, dear God, remember, you cannot do this. It's a lesson we learned from chapter 6. You cannot cancel that 2 out because it can't break into a plus or minus problem. But I can break it up. And I get negative 1 plus or minus 2 root 2. There you go. Which, if you look back at the work we did for this, that is quicker. Okay, cool. So yes, you will have to know the quadratic formula. Some of you guys should already know it. Right, but you have to know it for the test. You won't be able to write it down on a formula sheet or something. No, you have to know it. So the thing I like about this section is that the instructions say solve. They don't say solve using quadratic formula. So what's the only time I would use quadratic formula, really? If you can't factor it, right? Now, it will always work. I see people using it on very easily factored things just because they really don't like to factor. Why not? You're going to do a lot more work, get practice with quadratic, great. The bad thing is you're not getting practice with factoring. So I really, if you could factor it, because that's quick. Okay. So for example, number 10 is one I might see somebody doing quadratic for, even though you shouldn't. Oops. Those surefire method factoring problems, quadratic formula will eat it up. You don't have to factor it now, but you still should check it. See, number 10 says this. Now, no matter what, no matter which way I'm going to do it, what do I have to do first?
Adjust.
Yeah, it's a U, yeah. What kind of thing does quadratic formula work for if it's equal to 0, right? And what do I have to do first if I want to factor it? I've got to make it equal to 0. So no matter what, the first step is the same. Move everything over to one side. Oh, why did I make it 15? Thinking ahead. Now this is factorable because 3 times 5 is 15, and 3 and 5 make negative 8 if they're both negative. So you can do this the surefire method. For quadratic method, you would have, what would A be? 3. B? Negative 8. Good. Don't forget the signs. C would be 5. You can throw it in there. But this one you should be able to factor. 15, 3 and 5 to make both if they're both negative. Break this up, group it. Bam. Right? So be careful. I'll do the same thing on the test. I'll be very specific on a couple problems. Use completed square, use quadratic, and then I'll just say, solve these. And you have to use, hopefully, the best way.